Hello students, I am Sister Mary here. Welcome to 10th Maths NCERT Chapter 1 Real Numbers. Today we will study Theorem 1.3. Theorem 1.3 says, let P be a prime number. If P divides A square, then P divides A, where A is a positive integer. Now just in a simplest way, I'll explain to you this theorem, then we'll go for proof. What they are trying to tell is, if P is dividing A square, if P is dividing A square, then we have to prove that P also divides A. This is what we have to prove. So what the theorem says, P is a prime number and A is a positive integer. So A is some positive integer, P is a prime number. So if P is dividing A square, then P also divides A. This is what we have to prove. In easiest way, I can tell you that if 5 is dividing 10 square, then 5 also divides 10. If 5 is dividing 10 square, 5 also divides 10. This is what the theorem we have to prove. So let's begin. Proof. Let the prime factorization of A be as follows. You consider A as some composite number. Okay. For example, let's consider A as 10. Okay. So if this is a composite number, then the factors of A would be P1, P2, P3 and so on. Where P is a prime number. You know the factors are always a prime numbers. So if A is considered A as a composite number, the factors of A would be P1, P2, P3, right? Now if both the side, if you square it, then we will get A square is equal to P1 square into P2 square and P3 square and so on. So if you are squaring 10, if you are squaring a square, then naturally the factors of 10, we will square it, right? I hope up to this 2 steps you have understood. Now, as per fundamental theorem of arithmetic, I already explained to you the fundamental theorem of arithmetic. What does it say? Every composite number can be expressed or factorized as a product of primes, and this factorization is unique apart from the order in which the prime factors occur. Already I have explained to you, every composite number will have its own unique factors. It cannot be changed, but the order can be changed, but the factors cannot be changed. For example, if 10 is a composite number, then their factors would be 2 and 5. It cannot be changed. Now 10 cannot have the factors of 3 or other factors, 8 or some other factors. It cannot have. So 10 can have only 2 and 5 as their factor. This order can be changed. It can be 5 and 2 or 2 and 5. But the factor will not change. So that's what the fundamental theorem of arithmetic says. That the composite number can be expressed as a product of the primes, and this factorization is unique apart from the order in which the prime factors occur. So it can change the order, but it remains the same. I hope up to here it is clear. We said if A is some composite number, then P1, P2 will be the factors of this A. And if we are squaring both the side, then A square will be equal to the square of their factors. And we said, according to fundamental theorem of arithmetic, that the factors for the composite number remains the same, but order can change. So therefore, what can we say? Therefore, there cannot be any other prime factor of A square other than P1, P2, P3. Because A square, we got the factors squared it. So even if you square it, the factors are what? P1, P2, P3. Those are some prime numbers. Okay, this remains the same. There cannot be any other factor for A square. So that's what trying to tell. There cannot be any other prime factor of A square other than P1, P2, P3. So that means what? P must be 1 of P1, P2, P3. So P that divides A square should be from here only somewhere, either from here or from one of this number only this P will be. So since already we said A also is equal to P1 into P2 and P3. So A also is P1, P2, P3, and A square also cannot have other factors than these prime numbers, and therefore we can prove that P divides A also. Hence we have proved. So one more thing what you have to remember is, if P is a prime number and A is any positive integer, for example, you consider if P is some prime number and A is some positive integer. So if P divides A square, then P also will divide A. If P is a factor of A square, then P also will be a factor of A. I'll just explain it in an easy way. If we say that if 2 divides A square, if 2 divides 10 square, then 2 also will divide 10, right? So same way, if 2 is the factor of 10 square, if 2 is the factor of 10 square, then 2 also will be a factor of 10. So that's what you are trying to tell. If P divides A square, then P also will divide A. If P is the factor of A square, then P also will be the factor of A. I hope this theorem is clear to you. Thank you and God bless you.